So, what is 9 to the third power, everyone?
729.
So I would write 729, but that's not it. It's not my full answer, because what am I missing? I'm missing that k to the 6th power, so I just need to add that on to my answer. I don't know what k to the 6th power is, but it still has to be part of my value. So do the same thing with number 12. Who wants to take a guess at how you would write number 12? 12. Cooper?
Positive 49, M3, M2.
Very nicely done. Could I have multiplication signs between all of those?
Yeah.
Yeah, same thing here. I could add a multiplication sign between the 729 and the k to the 6th, and I could have multiplication signs between all of these. I just don't need them. But I could have them and be just fine. 13. What do you think? Do you think there's a value on 13?
No.
No, there's not. Because you can't cube a number when we don't know what p is. Because what comes first? Exponents or parentheses? So we solve parentheses first. And because I don't know what the answer is inside parentheses, I cannot cube it yet. Does that make sense?
Yes.
But can I answer the last question? Yeah. So do the last one. Who wants to take a guess at that one? Brock?
216 a plus b into the parentheses and then the 2.
Excellent. Nicely done. So variables you cannot give a value to unless they give you a equals whatever a equals, but we're not there yet. So you can only solve the ones that are number formed. Questions? This is going to be part of our homework tonight, okay? The other half is going to be the negatives. So we ready for notes? Okay, let's go to the green page that we just glued into our notebook. And the first one is we're going to talk about zero exponents. Zero exponent is an exponential rule that you just need to have memorized. Okay? It says any number except 0 raised to the 0 power is defined as blank. So if I have 1 to the 0 power, what do you think it might be? This is going to be tricky. Kansas?
0.
Nope. Jared?
No.
It is going to be 1. Which means 1 to the 0 power is
1.
2 to the 0 power is what? 1. 3 to the 0 power is 4 to the 0 power is, which means any number to the 0 power except what number?
0.
You cannot do 0 to the 0 power. Any number though besides 0 raised to the 0 power is going to be 1. That's all it is. So that rule just has to be memorized. Otherwise, you'll never remember it. The negative exponent rule is the rule we need to focus on the most because it is tricky. So when I say negative exponents, okay, I mean the exponent is negative, not the base. Do you guys see the difference between yesterday and today?
Yes.
Okay, I'm not saying negative 4 to to the third power, I'm saying 4 to the negative third power. Does that make sense to everyone, the difference? So when you see an exponent that is negative, you are not allowed to have a negative exponent. You must change it. Okay? In order to change a negative exponent into a positive exponent, because we need positive exponents, not negatives, okay, you're doing the reciprocal. So if I have x to the negative n power, what's the reciprocal of that? What do you think?
Negative x to the n power.
Nope, negative would be the reciprocal of positive.
Negative n to the x power.
What?
Negative n to the second power.
Nope, that's not reciprocals. Where did we learn the word reciprocal, and what notes? Fractions. So what's...
Negative n to the x.
Nope. Stop with the negatives, guys. Think of fractions. We did it when we divided fractions.
N to the negative x power.
Kansas?
X to the 1nth power, or?
Nope. Okay, if I go back to my fraction notes, dividing, we did the reciprocal. What did reciprocal mean? So I did 1 over 2 became what?
2 over 1.
And negative 10 became what?
1 over 10.
1 over 10. So what would reciprocals be?
N to the x power.
Negative.
What do I put, if I need it to be a fraction, what do I put x over negative n over? What?
N over
1 over x to the
x over
What do we always put fractions over?
1.
Always put it over a 1. Now I want the reciprocal of that. What's the reciprocal of that? 1 over x to the nth power. So it is the reciprocal, meaning instead of it being on top of your fraction, it goes to the bottom of your fraction. Instead of being your numerator, it goes to your denominator, and you get rid of that negative sign. Because by changing it to the reciprocal, by flipping it, you're getting rid of that negative sign. Okay, so here's what I mean by that. Makes more sense when you do it with numbers. If I have 5 to the negative second, okay, 5 to the negative second, I need to rewrite using positives, which means I rewrite it as 1 over what?
5 to the second power.
5 to the second power. Because I want that exponent to be a positive, and in order for it to be a positive, it has to go from my numerator down to my denominator over a 1, and now I can solve. Because do I know what 5 to the second power is? What is 5 to the second power?
25.
Which means my answer is going to be, it's not going to be 25, it's going to be 1 over 25. Because if 5 to the second is 25, 5 to the negative second is 1/25.
Oh, because then it...
Because all the negative is doing is making it turn into a fraction. Yes, Brock?
Does that mean that technically you could just do 5 to the second power and then put a 1 over it?
Technically, yes. Reason I wouldn't is because problems, if you notice, the farther you go down, get more complicated. But yes, technically speaking, that is correct. So everyone do number 16. So, first of all, how do I rewrite it?
1.
How do I rewrite it using positive exponents, everyone?
1 over 8 to the second.
So if they ever ask you, how do you rewrite it using positive exponents, that's how you do it. That's how you would rewrite it. Not how you would solve it, but that's how you rewrite it. Does that make sense? Now you solve it, which means 1 over 8 to the second equals what? 1 over 64. 1/64. So like here, when we see these directions, do you see how it says write the expression using positive exponents? Do you guys see that line?
Yeah.
That's the first part. Then when it says then evaluate if possible, what does the word evaluate mean? Solve. So when you see the word evaluate, you need to solve. And then it says if possible, because is it always going to be possible to solve?
No.
We found that out in the blue notes, right guys? It's not always possible to solve. Okay, we're going to skip 17 through 20. So no one should be working ahead. Let's go down. We can look at these other problems. So if we look at 21, I now have two numbers. They both have negative exponents. So first things first, rewrite them using positive exponents. That's always your first step. Rewrite it using positive exponents. Aubrey, take a guess. How do you rewrite it?
1 over 4 to the third power, times 1 over 7 to the first power.
Excellent job. Anyone have any questions on that? Now what do we do?
Evaluate.
You evaluate, which means you have to solve. So, 4 to the third. Do that first, because exponents comes first in order of operations, right guys? 4 to the third is?
64.
So how do I write that?
1/64.
1 over 64. And 7 to the first is just 1/7. And do we know how to multiply a fraction by a fraction?
Yes.
So multiply. Blaine, what'd you get? 1/64 times 1/7. What do we do?
Multiply 64 times 7,
Mhm.
and then multiply 1 by 1.
Uh-huh. Yep. So James, what did you get, bud?
1 over 448.
Would you all agree with him?
Yes.
Good, you should, because that is the correct answer. So just like the zero exponent rule, the negative exponent rule has to be memorized, because it's one of those rules that if you don't memorize it, you're not going to know how to do it, and you're going to get the answer wrong. Like, you can trust me on that, you're going to get it wrong because you won't remember it. So make sure you memorize that negative exponent rule. So we're going to skip 22, and we'll come back to it. Let's go to 23. What do you notice about 23? There's a positive exponent. Do I change that positive exponent at all?
No.
No. So I would just rewrite it as 3 to the 4th, but I would rewrite it over a what?
1.
A 1. That way it's in a fraction form, but I'm not doing the reciprocal. I'm not flipping it because it's positive. You only flip the ones that are negatives. Which means the second one, the 9 to the negative second, should be rewritten as what?
1 over 9 to the 9.
Is there any questions on that part? So part 1, rewrite them so they are all positive exponents. Step 2, solve the exponents. So everyone solve 3 to the 4th and 9 to the 2nd for me. Riley, what's 3 to the 4th?
21.
3 to the 4th?
Oh,
Okay, try that again. Cole, what's 3 to the 4th?
81.
You should have told me 81 over what?
1.
And then 9 to the 2nd, everyone, is 1 over 81. And with our fraction rules, what does that mean?
You cross divide and then you
I can cross cancel because these 81s are just going to become what? Ones, which means my answer is just 1. So you see how we have to know our fraction rules as well with this? Okay, we're going to skip 24. We'll come back to it. Let's go to 25. This time it has a variable with it. Do we do anything different because it has a variable? No, it's exactly the same. So everyone rewrite it using positive exponents. Haley, how would you write it?
1 over x to the 9th power.
Very good. Question, can I solve this?
No.
Which means my answer is what?
That.
I can't do anything else, so that's all it is. I don't know what x is, I cannot solve it. Okay, let's do 27. A little bit different, a little bit more. Do them separately, do them one at a time. It says r to the negative 6th power. Rewrite that using positive exponents. Focus just on that first one, r to the negative 6th power. Betsy, how do I rewrite r to the negative 6th power?
R to the 6th power.
Very good. 1 over r to the 6th power. Then I will focus on the s to the 0 power. Well, what did we learn? What is s to the 0 power? What's anything to the 0 power, everyone? 1. So I'm going to write times 1. Because s to the 0 is 1. It's not s to the 1st, it's just a 1. That s essentially goes away. Because whatever number you plug into s is automatically going to be a 1. Then it says t to the 11th. Do I need to rewrite that using positive exponents? Which means, how do I write it?
T to the 11th power over 1.
And I'm going to put the t over 11 over 1. What should I put the 1 over?
1.
A 1. I would make them all fractions just because it'll help visualize a little bit easier for you. Doesn't mean you have to, but it's easier to visualize in my opinion. Now what do?
Evaluate and solve.
I evaluate and solve. Technically I can't really evaluate it, right? Can't solve it, there's no numbers, is there? But can I condense 3 fractions into 1 fraction? Yes. Because what is 1 times 1 times t to the 11th? T to the 11th. Because there's always a 1 in front of every variable. That's one of those other invisible math rules. And then what's r to the 6th times 1 times 1?
R to the 6th.
And that right there would be your answer. You can't go any further. Questions?